Hello, everybody out there. I'm Thomas Schütte from PLASUS, and I want to present you our Emicon standalone system today. I want to demonstrate you the features and advantages of this spectroscopic plasma monitoring system, and I want to show you what is possible beyond the classical PEM system. PLASUS is a company located in Germany, and we are specialized in developing and manufacturing spectroscopic plasma monitoring and process control system since 25 years now. Talking about the plasma emission monitoring, this is actually a well-known and well-established technology in plasma diagnostic and plasma processing. One of the big advantages of this technology is shown here. It's actually the simple setup. All you do is, or all you have to do is to catch the light of the plasma and analyze plasma. So here the sketch on the left-hand side and here a real application on the right-hand side shows that do you need some sensors to catch the light? And the second advantage is you do not disturb the process itself. You just make use of what is already there. And to be honest, you just make use of that, what you see already with your eyes. The plasma is now radiating from the UV to the infrared region. And now, depending on your data acquisition system, you can make use of these wide range of information. And what a classical PEM system does is that it just takes out a very small part of the spectrum for one line. For example, in spattering application, it's basically the metallic line, and here in this spectrum, it's a silicon line. However, there is so much more information about the plasma from the different lines of the species in the plasma. And that actually we make use in our spectroscopic plasma monitoring system. We acquire always in real time and simultaneous the complete spectrum with a broadband spectrometer. And this now we make use of, and we analyze the different species in the plasma. And how we do this is shown here. You have the spectrum here on top and the upper diagram, and you see the different lines. You have, for example, the argon line in red, the silicon line in blue, but you can also monitor the oxygen line or the nitrogen line for the gases you want to put in. And now on the lower diagram, you see the monitor tracks, and this is actually what you make use of in your process. And you see everything is stable until you open the valve for the gas flow, and here it was an air gas flow, and the nitrogen line and the oxygen line comes up and shows you the difference. If you now come back to a classical PEM system and look at the silicon line, you see the silicon line didn't even notice if there was a change in the plasma. So it's very obvious here from this very simple example, the advantage of a spectroscopic system and to get a better and more comprehensive view on your process. And for this, we have actually set up our Emicon series, and I wanted to show you the different features which are included. I wanted to start with the spectroscopic features. Here you can input up to 8 channels, so you can look at 8 positions simultaneously. Each position has a spectrometer channel behind and will really acquire the data from 200 to 1100 nanometer. You can add on also external sensors, information, for example, from the target voltage or from the generator power, or maybe even from the lambda probe, and combine them. We have a new feature, a pulse and hyperpulse feature. Here you can monitor simultaneously the pulse curves of current and voltage, And of course, beside data acquisition, you need to have some control features. Here we have included PID control and DIO outputs. So you really can set up a PID control for reactive gas flow, for example. And here we have several output channels available in different configurations. Everything is set up in a rack box. It has an integrated processor unit inside for standalone operation. It's a Linux-based firmware running there for 24/7 duty. And everything is configured via a Windows PC. Integrating to your PLC, of course, is also possible and necessary if you want to go for a production line. So we have interfaces, common standard interfaces like Profibus, Profinet, or EtherCAT, or a LAN API for integration. So it's very easy to integrate this system into your overall system control. Besides the system itself, you need some kind of eyes of your system, and here we provide several types of optics for in-vacuum and ex-vacuum with coating protection devices, so they can stay rather long in the plasma without any changes or coating of the optics. We have feed-throughs and fibers, and we have pre-assembled optics here, which are ready to use. And last but not least, we have our coating protection devices in different sizes. So you can put them on several viewports if you want to stay out of the plasma, but protect your viewport from coating. This is for data acquisition. Now going for the data evaluation. Somehow you need to know which line belongs to which elements. And here we provide our offline analysis spec-line software, which has a database included for atoms and for molecules, which is still unique in the world. And you can put in your spectrum easily into the software from our Emicon software and make an identification, an automatic identification, and you see right away which lines belongs to which elements. And now, making use of all these tools I have shortly introduced here, I want to show you some examples, what you can do with it. And I want to start with the reactive sputtering process. Here we wanted to make an aluminum oxide coating by a reactive process with aluminum target on this dual cathode, and we wanted to control the oxygen flow. The challenge was that the substrate was moving back and forth, and thus we have some kind of not really stable plasma conditions here, and we needed to make the control stable nevertheless. So what we set up is we make a ratio of the aluminum to argon, and this is very important that you make the ratio to keep this process running over a longer time to actually control the gas flow. And that is shown here. Here on the top, you see the spectrum of this process, the aluminum line, argon line, and oxygen line. And here below, I have only shown now here in this picture the ratio aluminum to argon. And there was a set point of 35%, which gives you then a reasonable aluminum oxide layer. And you see everything was stable. You see the fluctuation, which comes from the moving back and forth of the substrate. But still, there was no running out of the work point. It was still, the set point was still kept, and you can make a continuous and stable coating here on this moving substrate. If you now go for larger applications, here like a web coater with an almost 2 meter long cathode, you need some kind of sectional control, and here you can go for the multi-channel system. So here we set up 3 channels looking across the target, and this is shown here also in this sketch. So you have 3 collimator optics, put them into the Emicon system, and now you can set up a sectional control with, of course, with the appropriate gas piping. This can also all be done in one system with our system. And in addition, you can even monitor the target voltage, which gives you some information about the target erosion. And with this information, you can easily recalibrate the set point of the gas flow control in the reactive process. So even in these rather more sophisticated application, the Emicon system can provide a safe and a very good control of the plasma process and thus of the production. Going on to a last application for sputtering processes, for reactive high pumps processes, we have here done a collaboration with the Fraunhofer IST, and here I wanted to show you how we integrated also the pulse curves of voltage and current into our process control system. We monitored the two cathode of this dual cathode application, each cathode with one channel, and in addition we picked up the pulse curves of voltage and current. We set up monitor tracks for the different lines. In this case, this was a titanium target, and we set monitor tracks for the voltage and for the peak currents. And this is shown here. And we made a control over a longer time. We want to show that this is really a long-term control possible. We did this over 7 days. What you see here at the monitor tracks are the spectroscopic lines for our oxygen, titanium, titanium plus, especially for high pimps. And we have the pulse voltage and the peak current. In the first 2 days, we established this process. There were some problems with the oxygen flow, but we could manage this. And then we needed to adapt the BID control to run stable. But after the second day here, or within the second day, this process ran continuously without any interruption for the next 5 days. And what I want to show you here that you can make use of a sophisticated and advanced process control system and run a process in production stable over a long time, over several days, even in this sophisticated application of a reactive high pimps process. But not only the sputtering processes are in the focus of our applications, but also PCVD processes. And here I wanted to show you an example of a microwave discharge producing a with high rate deposition a DLC layer. This work was done with our technology partner robeko in Germany, and we wanted to make sure that from each batch to batch the process is running the same. And for this we need to make sure that the process start conditions are always the same. And as you may know, in a batch process you will always have in the beginning moisture in the chamber. And this we looked at with our system to the OH and H line, and you can see here this rapid decrease of this intensity, which tells you that the humidity or the moisture is reduced. And then you can set a set point here and tell, okay, once it's below a level, system is ready, and you can start the actual coding, which you can of course monitor as well. I want to go into detail, not for this here. So you have the same condition at every time you start the process, and you can make sure that you have the same conditions. On the other side, in a PCD process, the chamber will be coated, and once in a while you need to clean the chamber, and this can either be done mechanically or by etching. And again, if you do an etching process, you can monitor the etching process with the Imicon system by monitoring the OH and H lines. These are particles coming from the walls, and by looking at the etching gas. And you can set point once the system is ready, is cleaned again, and you can go back to production. All this I want to show you here is that you can increase your production time by making sure and looking exactly when is my system ready, either for production or after cleaning. Last but not least, beside all these kinds of process monitoring, you can set up several tracks or monitor tracks also to look for faults which may happen in your process. Like, for example, an air leakage or a water leakage, or in a sputtering application, is my target done? Am I through with my erosion? And this you will see actually just shortly before. You will see either the bonding material, which is indium or copper, and then you can stop the process immediately. All these features can run besides the actual process monitoring and controlling. Okay, and with this I wanted to conclude, and I hope I could show you that with this advanced technique of spectroscopic plasma monitoring and putting several sensors together, you will have a very good control of your plasma process, and it runs stable and continuously, and is capable to maintain production in production lines. We can provide optics for this, fibrous and indirect vacuum optics. We have 24/7 operation, and we think it's a good idea maybe to retrofit or upgrading existing PEM system and make use and enhance actually your process with this kind of control to go either for a more stable production or for new processes. And of course, we are ready, our system, to give data for IoT and Industry 4.0, which are needed in the future, we think, for sure, for artificial intelligence applications. Okay, and I will finish with our contact information. Again, we are located in Germany, but we do have distributors in Europe, North America, and Asia. And if there is any interest or questions from your side, please contact them or us. We will be more than happy to answer this. And for now, I want to thank you for your attention. And if there are any questions, I'm very happy to answer them now. Thank you.